All right, let's do series video example number 5. Stem of the problem says, given a function f such that f of 3 equals 1, and the nth derivative at 3 is given by the nth term there. A says, write the first 4 non-zero terms in the general term of this Taylor series of f for f around x equals 3. All right, so if we're doing a Taylor series polynomial, we need the original function at 3, and then we need the successive derivatives until we get the first 4 non-zero terms. So because f of 3 equals 1, and that's a non-zero term, I need a first derivative, the second derivative, and the third derivative to get 4 non-zero terms. So I'm going to do f prime of 3 first, which is plugging 1 in for n. Negative 1 to the first power is negative 1 times 1 factorial is just 1. All over 2 times 1 plus 1 is 3 over 2 to the first power, which is 1. So that would be what? Negative 1/3? Oh no, this is 2 to the first, excuse me. 2 to the first is 2, so this would be negative 1/6. All right, so that would be my f of 3 is my first non-zero term. F prime of 3 is my second. I need a third and a fourth, so I'm going to do the second derivative at 3. The second derivative at 3 is negative 1 to the second power, which is positive 1, times 2 factorial, so 1 times 2, which is 2, all over 2 times 2 plus 1, so 5. And now 2 to the second power, which is 4. Factor of 2 will simplify out here, and I think we end up with positive 1/10. All right, last one we need to get done is the third derivative at 3. So plugging 3 in, negative 1 to the third power is negative 1, times 3 factorial, which is what? 1 times 2 times 3, so 6, all over 2 times 3 plus 1, I think it's 7, over 2 to the third power, which is 8. And let's see, we get a factor of 2 there. Negative 3 over 28. Scoot that over so we can see it. So these are, if you use f of 3 equaling 1, those are going to be the coefficients of our Taylor polynomial. So let's go ahead and write f of x here. F of x is going to be the output at 3. So 1, coefficient for the first term is negative 1/6 times, we're centered at 3, so x minus 3 to the first power, all over 1 factorial, which we don't need to write. Second derivative coefficient, so plus 1/10 times x minus 3 to the second power, all over 2 factorial, minus 3/28 times x minus 3 to the third, all over 3 factorial, plus dot, dot, dot. We need to do the general term now. Now the general term is just going to be the coefficient comes from this up here. So it's going to be negative 1 to the nth, n factorial, over 2n plus 1, times 2 to the n. And that's our coefficient, each term here. But we still need to do the x minus the center, 3, and it's to the nth power, right? All over the denominator, so n factorial, plus dot, dot, dot. I would probably go ahead and simplify this down a little bit. You could leave it there if you wanted to, but I'm just going to clean this up a little bit. We'll still end up with 1 minus 1/6 x minus 3 to the first. 2 factorial is 2 times the 10 in the denominator here will be 1/20 x minus 3 to the second, minus, this would be, what, 6? If I take 1/6 and multiply it there, I will simplify out a factor there, so I'll end up with 2 times 28 in the denominator, which is 56, 1/56 x minus 3 to the third. You don't have to do that simplification. I'm just kind of messing around here a little bit with it. And then it's plus dot, dot, dot. And the only simplification that I see up here that's worth anything is n factorial divided by n factorial. So we'll end up with negative 1 to the n times x minus 3 to the n over 2n plus 1 times 2 to the n plus dot, dot, dot. All right, let's go ahead and jump down to B. B says find the radius of convergence for the Taylor series. So what we have up here is our nth term, right? And I'm going to use the ratio test to be able to do that, or to be able to see what that is going to give us. So I want to do the limit as n goes to infinity of my nth plus 1 term. Now, I'm going to be taking the absolute value of this here. So the absolute value of negative 1 to the n is going to change to be positive. So I'm not going to need to worry about that. So I'm going to do x minus 3 to the n plus 1 power over 2 times n plus 1, right? N plus 1 in for here. We're going to need to distribute that too. Extend this out a little bit. And 2 to the n plus 1. Divided by the nth term, or multiplied by the reciprocal. So 2n plus 1 times 2 to the n over x minus 3 to the nth power. All right, let's start cleaning this up a little bit, doing some simplifications. Still have the limit as n goes to infinity. Absolute value. I'm going to do x minus 3 to the n plus 1 over x minus 3 to the n. If I'm going to subtract those powers using my power properties, I think I'll just end up with x minus 3 to the first. I think 2 to the n over 2 to the n plus 1. I think there's one additional 2, so that's going to be divided by 2. Let's see, 2n plus 1. I'm going to see if I can do any simplification here in just a second. I see what? Times 2n plus 2 plus 1, which is 2n plus 3. So I'm taking the limit as n goes to infinity, and x I'm just going to treat like a constant here. So even though these are different terms, plus 1 and plus 3, 2n over 2n as n goes to infinity is going to be about the same infinity. So that's really going to be 1. So that I'm going to end up with the absolute value of x minus 3 over 2. And because this is ratio test, remember this will converge when this value is less than 1. And I can pull out that 1/2. I guess I can show it here really quick. Oops, x minus 3. Right, this is a positive 2. It's always a positive 2 in the denominator, so I can pull it out because it's a factor. And so this is still going to be less than 1. Multiply by 2, so I can say that this is going to be absolute value of x minus 3 is less than 2. So we are centered at 3, which is what we know. And our radius is going to be 2. So our radius here is 2. And we could put a convergence here, right? Now, if you wanted to, you could extend this out, right? We could call this a negative 2 is less than x minus 3, which is less than positive 2. And we could add 3 and say 1 is less than x, which is less than 5. And since we know we were centered at 3 from the stem and from problem A, we could say since we're centered at 3, we have a distance of 2 in each direction, so our radius is 2. But we can see that from that point right there as well. Now, the one thing about finding the radius of convergence that's really nice is we don't have to do the endpoints. Okay, we don't care if the endpoints are going to converge or not. Okay, if we wanted the interval of convergence for this one instead of the radius, we would then need to take the endpoint of 5 and the endpoint of 1, plug it back into our nth term up here, and then test each endpoint for convergence. But because it only wants the radius, that's going to be nice and handy for us. We just need to get to this point to be able to see our radius of convergence is 2. All right, let's jump down to C then. C says use the first 4 non-zero terms of f of x to estimate f prime of 3.1. So we just want the first 4 non-zero terms. Luckily, we got, I think it's nice because we don't have to do the general term. And it only wants the first 4 non-zero terms of f of x. So I'm going to pull those back up from letter A up here where we wrote out our first 4 non-zero terms. So I'm just going to copy it really quick for us. I'm going to call this f of x equals 1 minus 1/6 x minus 3 plus 1/20 x minus 3 squared minus 1 over 56 x minus 3 cubed. So for this one, I'm just taking a look at the polynomial from up above. It wants f prime, so let's go ahead and take f prime. We don't end up with the first three non-zero terms anymore because the derivative of 1 is 0. But we get, what do we get here? Negative 1/6. Yeah, negative 1/6 here, sorry. Plus 2 times 1/20 is 1/10. X minus 3 to the first. And our chain rule is 1. So I could write times 1, but I'm not going to. 3 times 1 over 56 is just what? Negative 3 over 56. That's not divisible by 3. So x minus 3 now to the second power. And if I'm estimating 3.1 into my first derivative, I want f prime of 3.1. So negative 1/6 plus 1/10. 3.1 minus 3 to the first minus 3/56. 3.1 minus 3 to the second. And simplify to your heart's content at this point. I'm going to leave it as it is. If you have any questions, please make sure to email me.